Laplace Transforms, another concept which makes no sense until 3 years later into your engineering degree. And if you're one of those ambitious students, this will just be a video to help you pass your unit. It's not on how to uncover the mysteries of the universe, I'm sorry. But the point of a degree, a university degree, if this is why you're here, is to give you a degree of freedom. You need contrast and scale because that's how your brain makes sense of things. Fill your brain with tools, so then you can understand which are worth improving. So although you may not really understand what a Laplace transform is, where all the equations come from, what E is, why E looks like it does, don't worry about it until you have a grip on mathematics. Otherwise, nothing else is going to make much sense. So sometimes a mathematical equation will be easier to solve if we simplify it. Everyone has an intuition behind this concept, so it should come to no surprise that Laplace transformations are no exception. Nearly everything in maths is for the sake of simplification, to simplify logic to our feeble human brain, monkey minds. So yeah, Laplace transforms just help us grasp the universe better. So this is a Laplace transformation. Look at it, isn't it fantastic? They got a curly L going over there. They've got the beautiful F and an S. It's very aesthetic, but what the hell does it mean? What is that? What's going on here? Why is E there? Like I said, this is not to uncover the mysteries of the universe. I'm just going to show you how to use it. So let's find the Laplace transform of ft equals to 1. Why has organistry? Why is organic chemistry and what's going on in this background? It looks cool. Okay, that's why. Okay, so fine. I know. There's a bit to unpack there, but I'm just going to show you how to use the formula. So let's say you're asked to find the Laplace transform of some function, and we're just going to go with 1 today, because I think that's what it's a good place to start. 1 is always a great place to start. First step. This is symbolism of the first step. Okay, so just chuck it in, right? And because this is an improper integral, you do have to take the limit of it. Why? Because how do you compute the area under something infinite? There's no finite area, so you just take whatever is as close to infinity as possible, and you take the area of that. Easy as pie. So there you go. Then you just integrate E minus st in there, and you just get 1 over s. That's the Laplace transform of 1. It's not bad, huh? It's not bad. And the inverse, when you're asked to find the inverse Laplace transform, all it means is that you're going to have some function in terms of s, and if you transform it back to in terms of t, what are you going to get? And, in this case, the inverse Laplace transform 1 over s is just 1. So now you know how to find them. Here is a table of common Laplace transforms. Most of them require a lengthy process of figuring them out, and feel free to go have a look. So it's easy to just read them off of a table and continue with more important questions at hand, like wouldn't it suck if you just had to find the Laplace transform of this every single time? It takes a long time. It's just easy to say, okay, Laplace transform of this, is this the inverse Laplace transform of this, is this, done. And oh yeah, remember the conditions, those are important. So what happens, you're probably asking, what happens if I get a question with 2 functions, sin t minus cos t? Good news, you can calculate the Laplace for each separately and then evaluate the expression. Just using this, what is the Laplace transformation of sine of t? Something like this, you just chuck it in here, and there's your answer. Okay, and you're probably thinking, all right, well, Laplace transforms, yeah, we won't always get easy functions, will we? That is correct, well done. Hopefully, I'm going to move on to a question that's slightly upper level, but I'm sure you can handle it. As long as you're familiar with integration by partial fractions, you should be okay. So there's a lot to unpack here. Your eyes do not deceive you that this is a lot. It is, okay? I'm validating your look of your shock, internal shock. It's okay to feel that way. So when we need to find the inverse Laplace transform of something, it is often better to split our function into parts. If we get something that looks like this, you always have to split something into parts, but if it's of this form, yes. There are rules for this. You can't always just split a large function into partial fractions. Make sure that you refresh your memory with this. I did do a video on it. Feel free to watch that. So using our table here, after we have put our equation into partial fractions and found their cofactors, we can just, take out a, b, and c, and then just find the inverse Laplace transform 1 over s minus a. And there you go. That is it. That's not bad at all. So now you know. Now you know. Yeah, now you know. That's supposed to be for something to fill out. So yeah, that's a general gist of how to use Laplace transformations. And yeah, thanks for watching.